Hello everyone, welcome to the channel. If you ever felt that math is confusing, intimidating, or badly explained, this channel is for you. Here, we simplify university level mathematics, explain ideas from the ground up, and turn difficult concepts into something you can actually understand. Let's learn math the right way. My name is Camilo Muyanga. Let's jump right in. So today we have this exercise. Determine whether the following sets are vector subspace. Well, to determine whether a set is a subspace, we have three properties. The first property is the set must contain the zero vector. I mean, the set has to be a non-empty set. The second property is the set must be closed under addition. What I mean by that is adding two vectors in the set must keep you inside the set. And the second property, the last one, the set must be closed under the scalar multiplication. What I mean by that is if we have an element of the set and we have a scalar, multiplying a vector by any scalar must not take you outside the set. What I mean by that is that multiplication has to keep you in the set. So let's break it down. So we saw like the first property, which is the set must contain the zero vector. So let's see if this set contains a zero vector. But there's something very clear here. So that our set contains the zero vector, it means all these four components must be equal to zero, right? So if I say that all these components they are zero, which means it's a zero vector, but then what I have here is x and y, they are now zero. Then x plus 0 is equal to 0, and 0 is going to be equal to 0, which is true. And we also have this property, and it says the last two, the subtraction of the last twos, they must be equal to 0 as well. So if I subtract z is 0 now, minus t, which is also 0, equal to 0. 0 minus 0 is 0, and is equal to 0. Then we have noticed that this set is actually a non-empty set. It means the set contains the zero vector. Very simple, guys. The second one is the set must be closed under addition. Let me remind you what I mean by that. I mean adding two vectors in the set must keep you inside the set. For instance, if I have, for instance, u, and I said that u belongs to a1 for sure, and for sure u must contains as well 4 elements. And then if it's in A1, if it belongs to A1, then it means the first two, the sum of the first two, they're going to be equal to 0, and the subtractions of the last two, they're also going to be equal to 0. And then if I have like V belongs to A1, and I'll say V is x prime, y prime, z prime, and t prime, and it belongs to A1, then it means because of the set, it says the first two, the sum of the first two, they must be equal to 0, and the subtractions, the last two, they also must be equal to 0. So now what I want to know if I add those two vectors, are they going to be in the set? Let's see. If I have u plus v, what is u plus v? It's x, y, z, t, because u, it's x, y, z, t, plus v, it's x prime, y prime, z prime, and t prime. If I add those two, it's the sum of two vectors. Of course, we're gonna add the first components, x plus x prime, y plus y prime, z plus z prime, and t plus t prime. So the additions of two vectors, right? We're gonna add up those components. It's actually what I did. And then let's see if the sum of these two, they are in this set. So that to this sum belongs to this sum of the vectors belongs to the set. It means the sum of these two, which is I would say x plus xy plus y plus y prime is going to be equal to 0. But what are you guys going to realize is actually I can commutate. What I mean by that, I can do x plus y plus x prime plus y prime is equal to 0. But we have said here in our hypothesis that x plus y is equal to 0. Then this is going to be equal to 0, and also this is going to be equal to 0. Then 0 plus 0 is 0, which is equal to 0. What I have now is, for now, the subtractions of these two also must be in the set. So we're going to have z plus z prime negative t plus t prime. It's going to be equal to 0. What I can do is z negative t plus z negative t prime to 0. I just multiply this minus 1 into the brackets, and then I just, commute it, which is also, a property of the sum. I can commute it. Then what I have here is I've said z negative t is equal to 0 plus z prime and minus t prime is also equal to 0, and is equal to 0, 0 is equal to 0. So it means it is also closed under addition. And the last one, we have to show that it's closed under the scalar multiplication. Let me remind you what it means. It means multiplying a vector by any scalar must not take you outside the set. And let me remind you, the vector must belong to the set. For instance, if I say u belongs, for instance, I say u prime, or whatever, it's just up to you. If I say u prime belongs to a1, it's going to mean that I will say x prime, y prime, z prime, and t prime. It means the subtractions of these two, if I say this belongs to what? A1, it means the subtractions of the first two, the sum of the first two must be equal to 0, and the subtractions of the last two must also be equal to 0. Then, if I have a scalar, I would say alpha belongs to the real number. If I multiply alpha times u prime, it means it's also has to be in the set. Let's see what I have. Alpha times y prime is x prime, y prime, z prime, t prime. Then I'm gonna multiply it, right? Then it's gonna be equal to x prime, prime, c prime, t prime. Then why I have it? So this to this alpha times u prime has to belong into the set. But to belong into the set, it must follow this property which says the first two entrances, the sum of them must be equal to 0, right? Then what I can do here, let's see what I can do is I can just factor out the y, the alpha. But I've said that this is equal to 0. Then when this is equal to 0, half times 0 is going to be equal to 0 as well. And the subtractions of this, the last twos, they also must be equal to 0. Let me remind you. Subtractions of them must be equal to 0. If I factor out, but then I've told you that this belongs to the set, which is 0. Then alpha times 0 is going to be equal to 0 is equal to 0. Because we said previously that u prime belongs to the set. If u prime belongs to the set, it means the first two components, the sum of the first two components must be, the sum of them must be equal to 0, and the subtraction of the last one, they also must be equal to 0. So then we have shown that this set satisfies all these properties. Then this set is a subspace. Thank you. Don't forget to subscribe, share it with your friends, and probably with people that are gonna need it. And please, see you in the next video.